Gabi.
Hi, Markus. Okay.
Hey, Alex.
Hey Marcus, can you hear me?
Yes, I can hear you. Hey, you.
So I guess you're already recording this, Markus. You already started.
Yes, it's automatically recorded.
Okay. And then we share it. So even if people don't join, they'll be able to see it. Okay, good.
I think it's even automatically uploaded to YouTube.
Cool.
All right, I can quickly share my screen so we have the agenda on this.
Yeah,
Can you see that?
we see the browser. Yeah. Yeah, we see.
Hey, Anna. Hey, y'all.
Hello. Hi, hello.
All right, maybe wait 1 or 2 more minutes. Hello, room. So many people sitting there.
Cool. You guys are on mute, but that's okay.
All right, let's give others 1 more minute, and then we just start. Okay, so I would say we just kick off this meeting. So welcome everybody to the first FabricX community call. Please remember that this is a public LFTT community call. Everyone is welcome. Use nice words, be nice to each other, respect others. Great. Okay, so Illy asked me to run this code today. Most probably he will run the other codes in the future. For the agenda today, we will start with a small update round where we every component of the Fabric X can give a short update round and share some interesting news. Then we have, I think, Ale and Arne presenting the topic Fabric meets EVM. And then we have some time for open questions by the community. And then we can have some time to discuss things you would like to speak about. All right. So, well, can I just ask the Order X team to highlight some updates on the development of the Order X? The room is on mute in case you're speaking. We cannot hear the room. The room microphone is on mute. No luck.
Yeah, maybe we should get back to them later once they figure out. But you're on mute, guys, so you need to. I think because this is being recorded, and if you may have not approved. Here it is.
Can you hear us now?
Yeah,
Yes,
yeah.
now we can hear you.
Right.
Okay, success. So I am Yoav, leading the Fabric X Orderer Squad, and currently we are working on two main epics. The first one is reconfiguration, and the second one is hardening and productizing the orderer. We had completed making the Order X crash fault tolerant and Byzantine fault tolerant. And now we are completing the journey to make it fully BFT fault tolerant by making it reconfigurable so that we can add and remove parties, change certificates, which are the things that are crucial for deployment and managing deployment, but also for kicking out a rogue party or a rogue organization. So that's our main focus, reconfiguration. We had completed making it possible to disseminate the config transaction across all the roles of the order. And we are now testing that we can reconfigure using restarts. And our next move will be to support add and remove parties, which are more involved as they affect the internal components of the ordering protocol. So that's our main focus and activities so far.
Great, thank you, Yoav. Cynthia Liran, do you want to update us on the committer?
Yeah, so from the committer, we have three quick updates. So one, we have been working on the endorsement policy that we had in Fabric, that we are supporting in Fabric X. So that's almost ready. And then second one is moving utility and then protocol from Fabric X committer repository to Fabric X common so that endorser and orderer can reuse them. And then finally, we are enabling the TLS communication between sidecar and the orderer. Yeah, that's it from the committer side.
Okay, cool, thanks. Yeah, let me quickly share the ongoing work in the endorser part. So this work is currently done in the Fabric Smart Client repository where we have the platform implementation for Fabric X. And currently we are working on two things. One is to upgrade or integrate the latest version of the committer X, version 017, that tag into our code and use that one. That's part one. And the other work item is to foolish the integration of the notification service feature exposed by the committer into the Fabric Smart Client. So we have a working prototype currently. I mean, we call this prototype because it's not completely implemented yet, but the polishing is happening right now in terms of configuration of that service, things like that. Is there anyone else who would like to share some news related to our open source components? Okay, I think that was a great update round. Thanks a lot. And I think Ale or Arne, if you guys want to share your screen and just walk us through Fabric Meets EVM.
Yeah, you need to unshare first, and then I can.
Okay, let me do that. All right.
Okay, so this work is preliminary work, joint work with the great and bright folks listed here, and as the title says, it's about Fabric and the EVM. This presentation will say Fabric a lot. Whenever you see Fabric, just think it's Fabric and Fabric X. So both platforms are meant as background. So quickly on the objective. The objective is to basically run EVM smart contracts on a Fabric or Fabric X network, unchanged, unmodified. So the bytecode doesn't change. The way you invoke the smart contract doesn't change. Is the Ethereum RPCs. So basically, clients will have the look and feel of talking to a fully compatible Ethereum node. And then internally, that's Fabric or Fabric X stuff going on. So why are we doing this? Well, it's two big reasons, but we think that there's a big there's a win for both communities. So it's going to serve the Fabric and Fabric X communities, and from that perspective, because well, all of a sudden we get access to a huge amount of existing Ethereum logic, battle tested, that has seen real world workloads and applicability. We improve portability across the two platforms. We provide a migration path for anyone who might want to switch L1s. And we also have a different avenue for interoperability. So the two platforms are already interoperable through other ways. And that's a new way in which we can have the two talk. From the Ethereum perspective as well, as an Ethereum developer, you get access to high throughput, low latency BFT L1. Not to say that this is not meant to disparage the existing Ethereum L1s. It's just to say it's another one, and it has its strengths undoubtedly. You can run your EVM contracts in a permission system, which some of the Ethereum compatible L1s are not, and you inherit Fabric's powerful governance model. So that's what you stand to gain if you come from the Ethereum world. The approach, I think we can focus on this side of the slide first, and we can see some of the icons of well-known Ethereum clients or SDKs, whatnot. They are meant to be talking to this component, this Fabric EVM component, as if they're talking today to a fully Ethereum compatible system. And this is meant to be just a black box, which because I have running my presentation in dark mode, it's a white box. But basically, it's meant to be just doing everything that's meant to be done to then commit these transactions and keep the world state on top of a Hyperledger Fabric or Fabric X network. So as it says here, we expose initially a subset of the Ethereum JSON RPCs so that these guys don't think they have to. They don't have to change. Internally here, we instantiate the reference implementation EVM from Geth. We instantiate it in here. We equip it with a state DB wrapper. More on that later. And then let's say when these guys, for instance, invoke this this API, it's called send raw transaction, which is the one through which most of these clients will request the invocation of a smart contract. What we do inside is we spin up this EVM, we execute the transaction, and then somehow we get a read-write set out of it. And this is where the touch point is. So far, all the stuff that I said so far was Ethereum stuff. And that's the touch point with Fabric, because out of the execution, we don't persist writes. We actually get a read-write set out of it. And then the rest is purely Fabric, because then we're going to have endorsement, ordering, finality. So stuff that Fabric knows. So this is really the touch point. So let's look at the architecture first. So first, just the white boxes. Forget the orange arrows for now. So we have a client, and as I said, this is a fully compatible Ethereum client. And this we don't maintain. We don't, whatever exists at the client side will do. So somehow our platform begins here with this API layer, which is compatible, as we said, with the JSON RPC APIs. Then we have an adapter, which is really, as I said, where the two worlds meet, because it bridges the Ethereum and Fabric worlds. It proxies the two protocols, and it orchestrates the flows such that this Ethereum smart contract invocation that comes in is translated into our beloved Fabric endorse, submit for ordering, validate, and commit. Then this adapter, in order to do that, it will have to instantiate the EVM. And to instantiate the EVM, you need to equip it with these objects. And crucially, one of them is the state DB, because at some point the EVM will have to might have to access some of the ledger state, so non-transient memory, so persistent stuff that's persisted in the ledger, and it will do so through the state DB. And we provide actually a state DB wrapper to the EVM, not the original one. And this state DB wrapper will do a bunch of things. It will first of all, it will wrap the Fabric world state. So this DB here is either Fabric or Fabric X's world state, and ways to access that. And internally, so whenever there's a get, we're going to go here and see what data there is. And we're also going to register writes because we don't persist them immediately. And as I said, as I anticipated earlier, we were going to construct read-write sets for that. Then we have also chain config and block context, because we need to provide a full execution context for the EVM. And then finally, architecturally, we have this Fabric connector, which takes care of all that follows the execution. So endorsing, ordering, committing, checking for finality. Let's now look at the flow, so we can focus at the orange arrows. First of all, a request comes in, let's say, to execute a deployed smart contract, right? The API layer forwards this to the adapter. The adapter is going to parse the request, perform the necessary verification, for instance, verifying the signature of the requester, working out the address of the originator of the request, and other things. Then we're going to go and instantiate the EVM. And we also need to provide the dependencies. And then we forward the request to this. So for instance, it's a call, so like execute this. The EVM is going to do what it does. And then at some point, it might have to access the state DB in order to satisfy reads or handle writes, and it will do so. At some point, the request is it bears saying that when a request is received, the state DB might interact with the ledger DB, with the real Fabric ledger. And after the execution is terminated, the adapter crucially collects the read-write sets that capture what was read and what was written and during that execution. And then finally, in step 7, the adapter with this read-write set, it does all the rest of the Fabric stuff. So it endorses it, and so forth. It sends it for ordering, checks for finality, and all of that. One word on the state model. The vanilla EVM StateDB is organized on top of storage slots. They're called sources. They're just 32-byte memory chunks that the smart contract can atomically read or write. And there's these two bytecode instructions, sload and store, that do exactly that. So they load stuff from the given address, or they store stuff to the given address. The EVM underneath has this authenticated key value store to manage the slots. But we got rid of that because we don't need it. So we equipped with this StateDB wrapper, which so we don't need the Merkle tree, and we just use directly Fabric style KVS. And so we have a naming convention, for instance, EVM a prefix, just to say these are EVM rights, and then we have the contract address. And then we have the slot key, which is basically this address here that these two operations take as operands. And then we just do gets and puts, like vanilla Fabric gets and puts to these storage keys. And obviously for reads, we're just going to retrieve whatever there was, and we document the fact that we read that at that particular version, because Fabric, as you know, Fabric LedgerDB is versioned. And then for writes, we just don't write immediately to it, but we just record the fact that this transaction wants to perform this write. And as we know in Fabric, this write will commit only if it's properly endorsed and there's no ledger conflict, and so on and so forth. So we have a demo for you. So I'm going to hand over to Arne. So I'll stop sharing. And, Arne.
You can. Well, okay. I like these colors.
You're on mute.
Oh yeah. Am I? Am I on mute?
No, we can hear you.
Oh, great. All right.
Yeah, maybe it's just me that I can't hear Arne, or
Dennis.
We hear him well. It's okay, Arne. We hear him.
All right, I'll just continue then. Yeah, we have a working prototype that proves that this concept can actually work, and it looks like this. I'm going to run a normal Fabric samples Fabric 2.5 network, and on top of that we have our application. The application will have the adapter, as Ali mentioned, and I'm going to run it through integration tests. So that's going to call the adapter, who is going to execute Ethereum transactions in the EVM, which reads from the world state.
Are you sharing your screen, or
am I not sharing my screen?
No.
Okay. Sorry about that. Have to get used to Zoom. Where do I do this?
There is a green share button in the middle of the Zoom, in the bottom row. Yeah, now we can see your screen.
Okay, apologies. All right, so there we go. I am going to run some integration tests, which are calling our demo application, which executes transactions in the EVM, which reads from the WorldDB. And one of the things we'll put in the WorldDB is a Tether USDT smart contract. So just a normal classic stablecoin smart contract as you will find it on Ethereum. And we have a couple of Fabric users in here who are connected to this Fabric samples network. We have a component, a notifier or committer, who connects to the peer, to the deliver endpoint, to take in all the new blocks and put them in our local world state. We have endorsers of both organizations to keep things simple in the same application for now, which will endorse the read-write sets. And then with a user from org1, we submit it to the orderer. So all the ledger stuff, all the consensus is handled by Fabric itself. We also have Ethereum accounts, and these only exist in the world state, and we generate the private keys from our integration tests. So it looks like this. On the right, we have the block explorer, which is connected to these pairs and orderer that I mentioned. And on the left, we have our integration tests. And I'm now going to run them in debug mode so we can pause at certain transactions. All right, so to start, we are going to deploy the smart contracts. As you may know, smart contracts in Ethereum actually live on the ledger. So we have to take this deploy transaction as well and translate it to a read-write set. So I'll just go over that. And you'll see a block being added here, which is this new smart contract. We configured it with 1 million USDT to start with. And that's also recorded on the world state, of course. And now we're going to do a new transaction. So what you saw now was actually executing all these steps that I showed in the PowerPoint presentation as well. And we're now going to call the transfer function on this smart contract. And we're going to transfer 200,000 to another account. And then I can show what that actually looks like. So to the next. Simulating it first doesn't create a transaction. It's just the endorsement process. And then when we call commit is when we submit it to the orderer. So if we look here at the blocks, I can show what it actually looks like. We have the read-write set here. After it's committed, it's a normal endorser transaction. Everything is just the same as a normal Fabric transaction or Fabric X. And there are two relevant ones here. Yeah, this is one. So this is what Ale mentioned. This is what we use for storage. This is the address of the Tether smart contract, the namespace, if you will. And this would be the account of one of the users. And the value, every value is hex encoded 32 bytes. So if we want to see what we actually stored here, then I can convert it to decimal. And you can see that this is 800,000. So that means this is the owner balance after we actually did the transfer. And it means if we look at the other account, there is another storage here with another Ethereum user. Then that must mean that if I look at this one, yeah, this is the 200,000 that the new user actually received. So we can do Ethereum transactions on Fabric in principle. But let's also look at what is possible now. What we're going to do now is something that doesn't work on Ethereum Classic, but it does work on Fabric because of our execute order mechanism. We're now on a block. We're now on block 32. And we're going to simulate two transactions at the same time in two different environments, two different EVMs. On node 1, we're going to transfer some money from A to account C. And on node 2, we're going to transfer some money from node B to account B to account D. On Ethereum, these would have to be serialized, but as you can see here, we're going to submit these transactions at practically the same time from two different instances. And then what will happen is only one block is added with two transactions. And if we look at those, you can see them. Blocks. Yeah, sorry. Blocks. You can see them here. There are two transactions. I'm not going to show them both, but the principle is clear. We have executed these two transactions in the same block. So looking at this is, I don't know off the top of my head who it is, but it's going to be one of the values, 130,000. So that's the balance of user B. Right. So that's already working. Maybe Ale, we can go back to your slides. And this was the optimistic version. You saw me do two transactions of 4 accounts that were not related. So there's no contention on the keys. If we would do two transactions to or from account A, for instance, then it would fail. But we were very happy to learn that at least in these ERC20 contracts, which are very common, that's usually not a problem unless you have accounts that are just in very high demand. Still, we do want to look into how we can improve this. Either we say in the beginning, just use Ethereum account smart contracts that have low concurrency, but we do want to look into ways also to improve this so people can benefit from Fabric even more.
Yeah, thanks, Arne. So just one last slide, some other considerations. So there's the point on gas. So gas, we could, in theory, we could dispense with it entirely and just keep it for metering and halting, simply because so we're working on an execute order validate platform, and so the consequence of let's say a non-deterministic, for whatever reason, one endorser takes one gas more than the other, and then we don't fork. Worst case scenario, the endorsement fails. So we don't need to be so strict about this, and also we don't have the whole token economics aspect of it, because it's a permission platform, and so we could just dispense with it and keep it just for metering. When it comes to nonces, they are crucial in Ethereum to maintain replay attack protection. Fabric has its own mechanisms to handle that, so we think we should just keep them in order not to break clients, but we are confident that we can rely on Fabric's replay protection. When it comes to identities, we think there's value in keeping the two separate. So we have Fabric identities and Ethereum identities. And Ethereum identities would be treated in the way in which the EVM would expect. So there's a sender from transaction. There's the whatever level of access control is available today to Ethereum. We most definitely don't want to break that. On top of which, Fabric has its own layer with channel readers, writers, endorsement policies, and whatnot. And we definitely think there's value in keeping that as well. And I think it's up to us / the community to decide whether the two should have some relationships or should be kept entirely disjoint. So I think this one's still up for grabs. And then finally, there's Ethereum logs, which we think we should be able to handle with Fabric events and finality. And that kind of concludes the presentation. I don't know if there's anyone on the call who has any questions or anything to
Yeah,
bring up.
I have one. Can you hear me?
Yeah.
Yeah. Okay. So you mentioned you use a dependency graph to prevent MVCC conflicts, right? And the question is, why not just try and submit them? And if it fails, then try again, fix it?
Yeah, that should definitely work. Absolutely. Yeah.
I mean, that could be the optimistic approach, right? If you're using MVCC, it's not optimistic.
Yeah, absolutely. Absolutely.
We think we can get pretty far with that. Sorry,
right, so my point is that I think the mantra of this is we don't want to break the experience between these two, right? And there's no, so currently, I mean, I would need to educate myself a lot more to give you a good answer to this, but the point is that I don't think there's a way of feeding back and saying I couldn't execute this transaction because of an MVCC conflict. So that kind of might break the flow.
But you can just try again. But the Fabric EVM,
right? It could again, yeah,
again, try.
Absolutely. Which, I mean, if you think about it, is what you just did is you built a very rudimentary dependency graph, because you just your approach to approximating the dependency graph is you try, and if you go through, you're good, and if you don't, you need to retry again, which ultimately is a way of serializing according to, if you had known the dependency graph ahead of time, you would have done exactly that. You would have postponed this one, let this one go through first and so. But yeah, I absolutely agree with you. Yeah, in a way, the dependency graph is just a way of maybe removing some of the non-determinism when it comes to the retry logic and the backing off and all these kind of things. But yeah, I agree with you.
Yeah. The idea is that, at least in Fabric and also how the system works, is that most of the time there won't be conflicts. So why do the hard work of solving conflicts when mostly you won't use them, and especially when the system designed to fix these conflicts for you. So what I say, and it's not that you're doing something wrong, it's just that you're doing a lot of work mostly for rare cases that usually never happen.
Yeah, I'm not 100%. So you might be right. I'm not 100% sure about this though, because I think it's legal in Ethereum to say, let's say it's an account-based model, and so I want to say I transfer 10 and then I transfer 5 in rapid succession, and my expectation is that it will go through, because again, Ethereum is order execute, and so it will order the 10 first, the 5 later, and then you do -10 and then -5 in the next transaction, and both will commit. So there's no expectation of this ever breaking, and the way the smart contract handles the state is through a read, modify, write kind of thing. So it reads up, modifies, write, and then again the next one reads, modify, write. And so the conflict is kind of it's built in the smart contract logic. Now we're somehow we're speculatively executing these contracts, and if the second one speculates on top of stale state, well, that's meant to fail, and so then you have to retry again. But that's not kind of, I mean, this is because you were too fast, or because you didn't care about the dependency graph. So this only happened because you didn't care about the dependency graph. Because in the order execute world, it would never have happened.
So in EVM, it is allowed to submit. If you submit a multiple transaction, they are expected to run in this order you submitted them, not, and then the dependency graph is mandatory for you.
Right.
I mean, otherwise you just have to send them one by one.
Right. Pretty much.
Okay.
Yeah.
It makes sense. Yeah.
It's not mandatory, right? Because here the goal is to only replicate the contract, not the protocol of Ethereum. So, I mean, because here, I mean, we are supporting the EVM on Fabric, but it doesn't mean that we need to follow the protocol that Ethereum does, because in Ethereum there is no transaction failure.
Yeah.
But in Fabric there is a transaction failure.
Yeah.
So it's an, as you said, it's optional feature.
Oh,
That's what I feel. It is not compulsory, because we are not replicating the Ethereum protocol.
Yeah, I agree. Our main goal is compatibility, so it should be easy for developers to come from Ethereum to Fabric. So that means some contracts might not be compatible right away, but it would be nice later if we can offer that as well. But we have other priorities first.
Yeah, there's a question from Marcus, but I wanna add one note to what we just said. So, number one, Arne just showed that basically this is not, so it's not guaranteed that all of the workloads will have this problem. In fact, a very popular like workload such as ERC20 will not suffer from this one, provided that you don't have the same account transacting over and over again. And even if you have the same account transacting over and over again, there's nothing preventing this account from splitting itself into multiple accounts. Let's say Alice goes Alice A, Alice B, Alice C, Alice D, and then she transacts in parallel through these 4 accounts. But this is just a small parenthesis. Even when with the dependency graph where we serialize transactions that do read, modify, write, we're still shooting for pretty good performance, because with our with what Fabric and especially Fabric X can do in terms of latency and throughput, even if we serialize these and we have 1 per block, we're still pretty fast. So that's not that. I don't think it's a problem we're going to have. Luckily, yeah. Marcus, sorry, you had a question.
Yes, great, thank you. I mean, first of all, thanks so much for this presentation and the live demo. This was really cool. I really liked it, and I'm already looking forward to see this demo in the future, hopefully running on Fabric X. Fingers crossed. Cool. My question is regarding the endorsement and endorsement policies. So if I understand correctly, what you showed in the prototype demo is that you basically invoke the EVM smart contract, it executes great, and as an output you get a read-write set, which is then sent to 2 endorsers in that demo. They sign it, and then this transaction of repop goes into the ordering service, gets committed. Is this correct understanding?
Yeah.
Yeah, in the
Okay,
demo we're kind of faking it, I think it's safe to say, or at least both endorsers are in the same node or their keys. But I can show what it could look like.
Oh, wait a second. So,
Oh yeah, sorry.
this was just, I mean, to get back, me not being stupid to ask a question because I didn't understand what you showed. My question actually is, so, I mean, if you think, okay, let's see if this is going to be implemented and works fine, is then the general flow, like in Fabric, that the endorser will execute this smart contract, takes the result, signs it, and then the other endorser does the same, so that we basically follow the same scheme as in Fabric/Fabric X?
Yeah, very much so, yeah.
Okay, and so if we do that, is there anything special you have to consider if you think about reasonable endorsement policies in contrast to normal Fabric chain code? Is there something which you have in mind?
That's a good question, and I think it's going to boil down to the business side of whatever that smart contract is doing. And it might be that for some, a single org endorsement is sufficient, because ultimately, let's say somebody's issuing or managing some kind of ERC20 token from an organization, and so endorsers from that organization will be sufficient. Maybe you want to have endorsers and some auditor, or endorser and the central bank, like some different models. But then for others, you might just really actually go much more towards the Ethereum approach and say, well, you just need a majority or maybe the entirety of the network, they need to endorse this transaction for it to be valid. And so, I mean, as you know, the good news is that all of this is possible in Fabric. The only caveat will be on this side of the house. So if we go with what was suggested before, and we just have we handle MVCC conflicts with retries, that's not going to be a problem. It's something you can just easily do. But then, I mean, if we might realize that for some workloads, performance degrades. And again, performance, we should keep in mind that depending on the L1 we're comparing with, no matter what, we might still be exceeding expectations. But still, if we want to do better and we want to implement some kind of dependency graph, and we want to have an endorsement policy that says that I need a majority of endorsers, then you're in the business of implementing a distributed dependency graph, which is something that is doable, but it adds to the complexity and footprint of the system.
Right. Yeah, cool. Thanks. I have a second question, which is related to the state model. So when you were speaking about the state model, I was thinking, so how does this relate to the concept of namespaces in Fabric? Would we assume one EVM smart contract per namespace, like in Fabric, or having also multiple EVM smart contracts per one namespace? Of course, increasing the risk of, let's say, read-write conflicts a little bit more. Is there any, I don't know, is there a different issue introduced by using of EVM smart contracts than the standard Fabric issues?
I would say no. I would say no, because ultimately the only reason to go for a different namespace versus the same namespace is the endorsement policy. For the rest, I mean, this naming scheme guarantees that there's not going to be any collisions, nor are there going to be there's no two transactions write into execute in different smart contracts that can touch each other's states, but also that can influence each other's concurrency and so throughput. So ultimately, it's just a question of endorsement policy, really, in my view. I don't know, Arne, if you had a different idea.
Yeah, I agree. It's much easier for us right now to keep it in one Fabric namespace, and the Ethereum, the EVM, the way it stores it into the slots, the way it creates the keys already provides all the namespacing we need. Also because EVM has features like smart contracts calling smart contracts. That's a lot simpler if we have it in just one Fabric namespace.
Right. Okay, cool. Thank you. Any other questions from the audience?
Nitin has a question.
I was just thinking about the endorsement policy. I mean, since you have the smart contracts calling the smart contracts, so can you just not leave it to the Ethereum smart contract to describe the endorsement policy? As in, like, every function can describe who can call it, who can, and if you need a more nuanced thing, you can always insist on functions taking signatures and stuff from. So that way you don't have to worry about like when one smart contract is calling the other, whether their endorsement policies are consistent or not.
I mean, so on the access control to functions is definitely something that we can do, and we can do it at both the Ethereum and also the Fabric layer, because I mean, we can decide essentially here in this step already if whoever can call this function. And then later on, when we're executing in here, then there's going to be also a decision possibly based on a per function basis. But when it comes to endorsement policy, that's something that must be written in the namespace metadata. So when the namespace is generated, we set this endorsement policy, and then the committer will be enforcing that. But that's a choice that we make when the smart contract is deployed. We can revisit it by changing the endorsement policy, but that's not going to be on a per function basis. I mean, vanilla Fabric has state-based endorsement, but Fabric X does not. Plus, the EVM does not have this concept of state-based endorsement anyway. And the way you define state-based endorsement wouldn't lend itself to, it would not be a good marriage here. So ultimately, the definition of the endorsement policy is something that that must be performed for the smart contract by us, because the smart contract doesn't know it even exists.
But then for the entire namespace, you would basically just have the same endorsement policy for all Ethereum transactions. And that's fine. Because if we already have a quorum of endorsers, then we should be able to trust that they executed also all the policies within the EVM and the smart contracts.
All right. Sure. I had one more, but that's a bit futuristic. I was wondering, like, can you maybe support first-class composability, like by calling an external EVM contract, let's say, some Uniswap or some external AMX exchange, like just as an oracle, maybe just to get a value, just read a value from somewhere against.
So my 2 cents there would be that the EVM endorsers, so the component that actually executes the transactions, should be able to run offline and completely deterministic. But I do also think that we need interoperability as a first-class citizen for this solution as well. So we could indeed have, at least for going out, we could have our endorsers return attestation to the state of a certain smart contract in the form that Ethereum smart contracts can read, just by default as part of the core solution. And we also need some solution for the other way around, that we can have a bridge that can write trusted values to our real estate, let's say. I think that's important. Also in our calls with clients already, they mentioned that this is important to take into account.
Okay, yeah, very good.
Good. Just one last word on next steps. So we want to work almost from day one, not exactly, because we have done some preliminary work, just as Arne was saying, to assess feasibility, but the rest of the work we want to do in the community. So we have a Fabric X RFC coming very soon, where we just summarize basically the technical details, the approach, the why nots, and so forth. And also the repo that Arne showed with an initial end-to-end demo, and where we will be doing all of the work, is also coming as Hyperledger Labs. And yeah, so that's these are the next steps. So we really encourage participation from the community to work with us on this. It's going to be a nice project. Yeah. Thanks.
All right, great. Thanks, Ale and Arne again for this presentation. Pretty cool. Yeah. So once the RFC is there, I mean, please share it over Discord with everyone in the community, so we get most probably or hopefully a little bit of feedback into this cool project. All right. I think we have now 7 minutes left until the end of this call, which is deserved just for questions, interactions, comments by everyone who's interested. Just raise your hand and come up with your question if you like.
Yeah, so I have a question with respect to this, I mean, and the EVM support. So I remember that around 2018, right? I mean, so there was a effort, and then the EVM was added to Fabric. But at the time, I know, I mean, some of the maintainers, including me, I mean, we were questioning the motivation because, I mean, you take Ethereum, and Ethereum has a completely different protocol, and then Fabric has a different protocol. And then the contract is a small part of the whole blockchain application, right? And if the user is ready to change the protocol itself from public blockchain to private blockchain, and then even its execute order flow is different, there is an organization. I mean, so there are so many differences. So when they are, I mean, changing that significantly, I mean, this contract is a small part of it, right? I mean, they can write it in the Golang or Java or Node.js. So, because this work came to us, I mean, in the Ledger team, and then we said we won't do it because we believe that if people are willing to move from Ethereum to Fabric, I mean, they can recreate the smart contract because it's not very hard to do that. And later, I think it was done by one intern, and even they have a repo about it. Yeah. So my question is on that. So I mean, why the client want to do this?
Yeah, that's a really good point, and also something we have to be very conscious about. I think one big difference of how we want to approach it this time is that the API is completely Ethereum as well. You didn't see it in my demo, but part of the design is that the whole ecosystem of all the developer tools like Foundry or Hardhat and all the wallets like MetaMask, but also even managed wallets like custody solutions should be able to interoperate with the solution. So it's not just a smart contract. From a developer point of view, it's everything. It's just Ethereum. It's only the operators and the people who deploy it and the risk managers or whoever who need to know about the fabric part of it. But otherwise, it's a lot easier to switch actually. And also on the other side, the endorsers, we are still working on that design as well. But the idea is that it's also going to speak Fabric so that you can ask the endorser, you can just drop it into an existing Fabric network and submit transactions that are endorsed by the EVM. So yeah, it's those kind of things, the composability, the modularity, and also trying to adhere as much as possible to existing standards that we hope is going to be a lot easier for the community to adopt and for us to maintain as well. Do you think that makes sense?
Yeah. So I don't have the, I mean, I don't know what are the application layer, right? I mean, the wallet and those things, how they use it. So I don't know. So I need to look into it. I mean, how they use the smart contract and how we can reuse all of those wallet and then Web3 stuff just by using the smart contract, because they also use the same fabric block structure. I mean, the Ethereum block structure into some of the things. Right now, the block structure is kind of different. So that's what I do not know. Just using that Ethereum smart contract will enable us to use all the application layer that is available for the Ethereum. So I don't have the clarity, so we will find it out. Yeah.
Indeed, we'll find it out. Our hypothesis is that we can make it work if we make the translation well. But yeah, soon we'll ask for your feedback again and hopefully share some more progress in this area. Thanks.
All right. Yeah. So thank you everybody for joining the first FabricX community call. I think that's it for today. I would like you to invite posting for the next community call, possible topics for the agenda. If you have anything to present, to discuss, let's make this as interactive as possible. And with that, I think we just close the call. Thank you so much for joining today. Talk to you in the next meeting. Bye, guys.
Thanks. Bye, everyone.
Bye.
Bye.